Now let's look into the last distribution under this, that's a Poisson distribution. So first we will look into the history and the evolution of the Poisson distribution in statistical analysis. So the Poisson distribution was named after French mathematician Simeon Denis Poisson. So Poisson first published the distribution in 1837 in his work Researches sur la probabilities des judgments materie criminelle et en materia civile. So in that he has first published about this Poisson distribution. So this is nothing but the research on the probability of judgments in criminal and civil matters. So in that he has published his first first Poisson distribution. So, however, the distribution was not widely used until the 20th century when statisticians and mathematicians began to recognize its usefulness in a variety of fields, including biology, physics, and economics. One major milestone in the development of Poisson distribution was in the early 1900s when Swedish mathematician Carl Pearson introduced the concept of the Poisson process, which describes the occurrence of rare events over time. So later in the mid 20th century, the Poisson distribution was used extensively in statistical quality control and industrial engineering to model the occurrence of defects and failures in manufacturing processes. In addition, the distribution has also been applied to study the distribution of species in ecological systems and the spread of disease epidemics. Today, the Poisson distribution remains an important tool in many fields and is widely used in statistical analysis and modeling. So, as we have discovered, as we have discussed, the Poisson distribution was discovered by French mathematician Poisson in the early 19th century. So, Poisson was interested in modeling the number of events that occur in a given time or space interval. So he was particularly interested in the frequency of deaths among Prussian soldiers, which he used as the example to demonstrate the distribution. So Poisson noticed that while the number of deaths per year varied from year to year, the average number of deaths per year remained relatively constant over a long period of time. This led him to develop a mathematical model to describe the probability distribution of the number of events occurring in a fixed interval of time or space. So, assuming that these events occur independently and at a constant rate. So Poisson's work later expanded and applied in various fields such as biology and physics and engineering to model the occurrence of rare events such as mutations, radioactive decays, and defects in manufacturing processes. The Poisson distribution has since become a fundamental tool in statistical analysis and is widely used in various applications.